The compressors like this, they are used on the drill rigs also. The fact is that the compressor is the first unit, the first machine, which has to be switched on before the process of drilling, before we switch on all the other units. This one is electrical one. When we begin the process, we also switch on diesel compressors, others, but the first electrical compressor is the first one which should be switched on before all the other process. Later I will explain why. So, but nevertheless you should know that the compressors, this is the group of equipment which is widely used for the compression and transportation of the gases. Yes, if we speak about the liquids, we speak about what? The pumps, yes. If we speak about the compression and transportation of gases, we speak about the compressors. The big compressors which are used for the manufacturing of gas, for gas production, for transporting the gas, the general idea is the same. So they have the cylinders, they have perhaps the diesel engine or electrical engine, but the scale is quite different. While I have said that this compressor should be switched on before all the other units, because we, on the drill rigs, never mind new ones, old ones, all of them, or at least almost all of them, they use the compressed air for the remote control of other units. The driller, you see, this tower is about 55 meters. I'm sorry. Yes. It has about 55 meters. It has a lot of objects. People are not running here, there, and modern drill rig. I didn't test it, but I saw them. So the driller, it has the cabin. It has a lot of gauges, manometers, different tables, and he just controlling by the remote control. What is the remote control? Electrical, hydraulical, and pneumatical. So this compressed. First of all, these compressors are used first of all for the compressing air, for the remote control of different units. One of them, for example, here. This is the real one from the drill rig. So this is pneumatical coupling. Coupling, perhaps the better. What is it for? For example, when we have to switch on the draw box, yes, when we want to rise or lower the equipment, you see the rotary table and the draw box, they are connected to the same motor, but they don't work at the same time. That's why the engineers, mechanical engineers, they have to manage this some way to switch them separately, to switch one, to switch another, to switch together. It depends. So this kind of pneumatical coupling is used for the distance, for the remote control, for the switching on or switching off the drum of the draw box. How does it work? We give the compressed air to the special pipe goes here. You see, this is stable in one. Be careful, place. This is rotated. The compressed air goes through this shaft. It goes through the coupling, and this coupling, like this one or this one that is apart. So the compressed air goes inside this rubber chamber or rubber wheel. It is deformated, and we have contact between two shafts.
Okay.
The idea is clear for you, yes?
Yes.
When the air goes out, we disconnect the shaft. And switch in, off, switch off, switch. If you can drive a car, you have the pedal of the connection or disconnection of the
Yes, sir.
gearbox. How you call it then?
Airbox?
Yes, gearbox.
No, the gearbox you rule by the handle,
That's
but
it.
you have the special pedal to connect or disconnect the gearbox from the
Brake?
motor.
Accelerator.
Brake?
No, the brake.
Accelerator.
Cage?
Clutch. The idea is the same. In your car, you push the pedal, you disconnect.
Yeah, you can feel there's air.
Yes, here you feel it by the air, you have connection. The air goes out, you have the disconnection. Kind of clutch, kind of connection. So that's why we have to use one. This is only one of examples of the usage of the remote control of the compressed air. On the outdoors, I'm not sure that you can see it now, but when you have been before, you saw the receiver. The outdoor is here. How does it work with this equipment? Let me someplace, please. Don't go far away, but let me, for example, here. First of all, we have the filter. The same filter is in the drill rigs. It should be. Because these little hard particles which are in the air, as usual, we don't feel them or almost don't feel. Sometimes we feel them too late when we have some problems. But nevertheless, these hard particles are very harmful for this equipment. Don't forget that they are going under the high speed, under the high pressure, and these strokes of these hard particles, they can be very harmful for the equipment inside. So there should be the filters. The filters are obligatory. We don't have there, but under the real conditions, they have the dryers. Somewhere there. Air around it always has some water. Very little drops, but they are. And these dryers, they catch this water. They don't let these drops to go to the compressor. Why? Because we spoke a lot of times that the drilling process, we almost don't stop it. It goes on under the freeze, under the different hard and severe conditions. And these little drops, for example, if we have -10, we continue the drilling, and these drops of water will freeze somewhere in the pipes, and it will be the great problem because of freezing these water drops. In the laboratory, we don't need it, but under the real conditions, there should be the dryers to catch. This is the counter. It's just for the laboratory usage. It counts how many liters or cubic meters of the air goes through the compressor. So the inlet filter, the inlet light, the pipe. This pipe goes to the compressor. This pipe, the inlet pipe, it goes from the filter. It goes to the compressor. This compressor, you can see, it's obviously that there are two cylinders here. Yes, is it visible? That there are two walk-in chambers through cylinders inside. This compressor, it has two stages: the first stage, the second stage. Any compressor, if sometime you be in the industry, neither. If you see the small compressor in the drill rig, or you see the big compressor for the gas transportation, stations, the first stage is always bigger. If you have the task to find which one is the first, which one is the second, the first one is always bigger. Because we have the air, we make some pre-compression of air, and this portion of air, it goes on. So air, it goes on. The second stage, we compress it more. The first stage is always bigger, the second stage is always smaller. The mechanical part is rather simple here. So the first stage, it consists of two cylinders, two walk-in chambers. Inside it we have the pistons that go up and down. We have this special shape of, you see the body of the cover, it has the special shape. What for? This special shape, what is it for?
For compressing the air?
No, why it is not smooth? Why it is not smooth? Why it has such a, how to call it?
Because the pressure.
Yes, why does it have these caves, these lines? What for?
Because the pressure is like this.
It's not
The system of moving.
no idea.
You think you are almost engineers. You studied science at school. You should know it, you should understand it. Why?
Maybe it's because of temperature, no?
Temperature is certainly never or always, if the always is better. If you see this kind of shape of the some surface, it has some connection to the temperature. Why? Because we make the surface bigger, and it's better cooling situation, better cooling possibilities, yes, to take the heat of the gas inside. Am I understandable? Yes. Because sometimes I forget English words and I try to change them by another word, and I am not sure that this is understandable. So, according to the classic physics, according to the classic science, when we compress the air or any gas, the temperature of the gas is rising. Yes, and we have to cool it. This shape is for cooling the gas, and moreover, from the first stage, by this pipe, it goes to the cooler, it's not the refrigerator, it's cooler. It goes to the cooler, and in the cooler, you see, it goes inside the cooler, it goes by this pipe, it's just the air cooler. Sometimes it can be water coolers, for example, in the cars, they are with the liquid coolers, but this one is very simple, the air cooler. The air, it goes through the small pipes, this fan, it
Rotate.
throws the cool air.
Just for cooling.
Yes, it's just for cooling. This is just for cooling the radiator or cooler. Both of them are correct. And from the cooler, it goes to the second stage,
Smaller one.
smaller one. Here we have the safety valve. There are some safety valves on the top. The idea is the same. Here we have two cylinders, two pistons inside them, and after this, so we have the pre-compression here, the final compression there, and after this second stage, by this another pipe, it goes outdoors to the receiver. Why we have to use the receiver? If we need the compressed air, for example, to switch on or switch off the drawworks, you understand that it's not comfortable to switch on the compressor, to wait for the compressed air and then to switch on or off something. So the receiver keeps the compressed air, which is ready for the usage all the time. Here we have the gauges, one of them, the last one. Let me go there. This is an electrical gauge. So it has two contacts. We can regulate these contacts. I don't want to do it to regulate, but believe me that we can do it. It has minimum and maximum. When I switch the compressor, the pressure rises, increasing, and when it reaches the final contact, when it sees that the pressure is too big, it makes the discontact, the switching off of the compressor by its own, and it stays ready. When we use the compressed air for many times, we use it, the pressure decreasing, and it reaches the minimum level. We close the electrical contacts, they switch on the engine, and it works till it has maximum. So it is automatically. We don't interfere in this process. For you, perhaps you know, but you should understand that it doesn't switches on or off directly the electrical motor, because it has a big voltage, the big amperes.
Current.
How to say? Currency, yes. Big voltage, big currency. It doesn't switch it on or off directly, because it will be fired in a second. As usual, we have some more electrical units. The information from the gauge, it goes to this unit, and this unit switches on it or off. So, but this the problem of electricity. It's not our problem, but the general idea should be known. So the electrical motor is written here. It's 40 kilowatts. 40 kilowatts here, for example. Yes, the coupling or the clutch, the connection between the two shafts, You can see it here. So the shaft, it goes inside. Inside we have the crank shaft. Cranked shaft. What is it?
Like the previous.
Something like this. If you know how the motor in your car works, so in the motor, in the engine in your car, we have this kind of flame here, and it pushes the pistons. Here we have the opposite process. The crankshaft is rotating, it moves the pistons, and they compress their inside. So the crankshaft is inside. We'll perhaps the crankshaft here, but later I will show it to you. What else? Here under these covers there are very special valves. I will show them later. So we spoke about the valves of the pumps. Yes, that they let the fluid go in one way. Yes.
Yes.
Here we have the one these valves also, but they are very special. I will show them later. For you, this unit, what is it for? Easy. To check the level of the lubricant, of the oil.
Oil. Like in car.
Yes, like in the car. A lot of similar. What is it? If I'm not mistaken, I asked somebody. Somebody wanted to defend the laboratory work, and I asked, what is it? All the gearboxes have mushroom like this one.
Yeah, even in car.
And in car it's also, yes, but it's hidden.
Yeah.
You don't see it in the car, but it is. It's kind of breather. Breather. What is it for? To equalize the pressure outside and inside the mechanical part. Don't mix it with the pressure inside the pneumatical part. It's just for equalizing the pressure outdoors and inside mechanical part. Because now it's cold. When I switch it on, because of friction, because of different process, it will be heating. If the pressure here will be much more bigger, we'll have a lot of oil from different connections, and so every time we have to balance, to equalize the pressure outdoors and inside the mechanical parts. Is all the gearboxes has something like this, and in cars also, but you don't see it somewhere under.
So does it have only mechanical parts, right?
So electrical motor, mechanical part here, and somewhere from here we have the pneumatical part that the air goes through it.
Okay.
His name, please. The name of it.
The name of
Mushroom.
breather, like breathing.
Breathing.
In Ukrainian it's sapun. I don't know. I have no connection in my election. Breather is understandable, but what does it mean sapun? I don't know. Where it's from?
So these two cylinders, this one for the inlet of the air. This bigger one.
Yes,
Inlet, and this one is the outlet.
Inlet pipe out from the first stage to the cooler.
Cooler.
From the cooler to the second stage
outlet.
and to the receiver.
Okay. So when it's received, how does it indicate? Does it indicate on this side?
Yes. Be careful. Your favorite part of how our laboratory works. I will switch it on, but I want to stress your attention. This is the pressure after the first stage, the pressure after the second stage. The temperature, most interesting is the pressure after the first stage, because later you will see that the temperature is rising, it's heating. And we spoke, you go there to see it better, but be careful in this spot. We spoke a lot, when we spoke about the pumps, we spoke a lot about the pulsation of the pressure because of the work of the pistons. Do you remember? We spoke of the dampener and so on, blah, blah, blah. Here, on these two gauges, you will see the pulsation of the pressure in the air. How the arrow doesn't go smoothly, it will go this way, because the pistons gives the air portion by portion. So, and the same process is in the piston pumps. We speak, so we have the same picture of the pulsation. Я не чую. Не знаю, яка машина? Кія, то може бути Копея. Копея, Богдан Володимирович. Та на прохідній скажіть, я тут що можу. Someone blocked by his car. So they continue this polygon that we saw in particular, partly, but they continue the works about it. So here we have the same pulsation, but because of air. So you can imagine how big is the pulsation if we speak about the liquids, and more information, the gas can be compressed. The liquid, it is not compressing. So the pulsation of the liquids is much more damageable because the liquids are not compressible. Now it's very noisy to comment something, so look on the pulsation, look on the rising of the pressure, look the rising of the temperature here, and perhaps there
But why
also.
there is two? Them? Why,
First and
why there
second
is two of
stage.
them?
Before and after.
It's just for laboratory usage, to understand the pressure after the first stage and the pressure after. So
And this is for one stage.
yes,
another
this
for
is after the first stage. This one.
This one.
Yes. Very good.
I think this is the thermometer. This is gauge for the pressure, and the same here. The second stage. Under real conditions in the industry, they don't have a lot of these manometers. They just switching off. Perhaps they have one manometer to check the way whether it's filled or not. The general work to understand, but they don't have a lot of gauges for all the stages. Just see, and if you have some questions, ask. So be careful on this point. All the rest, I see, are safe. So I hope that you have general idea how does it work.
Yes, sir.
Perhaps will you give me the screens? What was the information here? So the technical information about this directly this compressor. Then the cross section. So the crankshaft here, the piston of the first stage, the piston of the second stage, the fan, the end from the side, the crankshaft, and the pistons inside the cylinders, the fan.
Sir. Is this one?
Is from this point of view, without is the cross section. Yeah.
Yeah, from here. Okay.
Okay, what else? Pictures of
The path.
the crankshaft, the connection rods. This strange tail is, what is it for? How do I think?
Where you can find this?
This one, what is it for? It's connection rod. One, this is connected here, and this is connected to the piston.
Okay.
So this is, what is it for? How do I think?
This for
No, think.
It's here, right?
This one, this one, this one, this one. It will be there, so it will move in this way. So this tail, what is it for? It's very easy, gentlemen. Think. For lubrication. It's in the oil, and it rotates very fast. And these tails, it throw drops of oil on the parts inside the mechanical part.
Sir, is it here where you put something else, like the lubrication oil?
Come, let me go there.
Like this one, you pull it out.
No, these connection rods, like this one, they're inside. So one end is connected to the piston, another one is connected to the crank shaft. So inside it.
It's here like this?
Yes, and this tail is in the oil.
Ah, okay.
And when it goes very fast, by this tail it drops, the oil drops on the different parts. So the piston I think it's clear. What else? The valves, I will show them real ones, open ones. The safety valve is very easy. It is kind of piston here and the spring there. If the pressure from the bottom is higher, it